Hello everyone. Thank you for having me here today. So, as you probably guessed from the title, my talk will be about UPnP and how to abuse the protocol. So, first of all, who am I? So, you mostly know me from Twitter, I guess, as x0rz. I'm French, so sorry for my broken English. I have been working in the InfoSec industry for more than 8 years, and I am now working as in a consulting company. So let's go straight to the main topic of the talk. So last March, Symantec reported about the Inception Framework group, which happened to be an APT, and they used a lot of IoT devices and UPnP to hide themselves. So what is interesting is that according to the report, we could abuse this protocol without any custom malware to be injected into the router. So this is interesting. And of course, the threat actors have been using this for so many years. This is how Symantec portrayed the attacks. So an operator from an unknown location was hopping through a VPS, and then 3 layers of routers to anonymize them. So, of course, I got interested and decided to find out how one could do exactly that. So, let's go into the... No, first, disclaimer, yeah. So, what you need to know about this research is that UPnP hacks have been around for ages. So, my goal today is to make it a little less secret and giving it more visibility. So, I'm not claiming any of this to be new. Of course, it is not really new, but hey, it's still being seen in the wild, so let's do something about it, right? So there's a lot of noise on the internet, continuous scanning from multiple parties like Shodan, Census, and all of the others. It's like internet party, you know. And this graph shows you the scan on UPnP, so more specifically the 1900 port on UDP for last year. So it's quite buzzy, there's a lot of activity going on, and what is interesting here is you can almost see a small pattern. So I don't know if there's any correlation, but when there are public research, you might have some people scanning more after your research. Like, for example, like on the right, you have like the Akamai research paper, and then huge spikes of scans. So, why are people scanning UPnP? What if I told you you can build your own botnet of routers without any single infection? Well, let's talk about UPnP. So UPnP stands for Universal Plug and Play. It's a set of networking protocols to allow devices to discover each other's and use them out of the box without any configuration. So it's literally plug and play. You can tell the architecture is pretty old because there is a lot of XML and SOAP, so like the late 90s. So yeah, you can say it's just a bunch of protocols used to remotely query or control a device. Well, what could possibly go wrong? So according to the UPnP specification, so by the way, all the specifications are open, of course, on the internet, so you can really read all the documents and find like a lot of interesting stuff. And that's what I have been doing, just reading the documentation. So there are 6 layers of protocols, and I will only focus on the first 3 layers. So discovery, description, and control. Discovery is basically the SSDP protocol, HTTP over UDP, using multicast for discovery. Then description. This is when the UPnP device will describe its capabilities. And finally, control, where the magic happens. You can query and control the device with SOAP. So it's kind of like RPC, but without any authentication, because, you know. So how does it work? Well, this is a simple example I'm going to explain to you. When, for example, peer-to-peer clients on your computer will request the router to open a port to make a direct connection, right? So it is also used by Skype and many other applications. So UPnP is one of the easy way to achieve that. Like when you are inside a LAN, we are behind a NAT, and you want a peer to directly access your host. So first, your computer will send a multicast, so it's HTTP over UDP request to discover if there are any UPnP-enabled gateway device on the network. So that would be the IGD. IGD is the Internet Gateway Device in the UPnP specification, and that is basically the router. So you are looking for the router, right? And the router will reply back with over UDP with the XML location of its control points, like so. And then the computer will ask the router to forward a particular port in order for like the peer-to-peer to work. So this is the control part. And finally, the router will just comply and say, OK, I open this port and the direct connection can be made. It's as simple as that. And this happens in like a few milliseconds, and you do not notice anything. But that is what UPnP can be useful for. And this is the more formal view of what is happening behind the scene. So first SSDP over UDP, then SCPD over TCP, and finally the control part with SOAP. This is just here for reference. What happens now if you send a discovery packet, so that is a search packet, over UDP on the internet to some random router? Is it supposed to reply back? Well, of course it isn't supposed to reply, because UPnP is supposed to be on the LAN. It has no, I mean, no sense to be on the internet, right? But sometimes well, the router will just, OK, here. So this is the first vulnerability. The discovery service shouldn't listen on the WAN interface, of course. And when you get something like that, you send an msearch with host as a local multicast address, because this is like a normal msearch packet. But you still get a 200 OK reply, even if it's like from the internet. So there's something wrong here, obviously. Don't need to be an expert to. So here is in blue is the server's response. If you're lucky, you can notice the location header pointing to a private IP address. So this is the description XML, right? So this here is the discovery phase, and is pointing you to the discovery phase. So now let's try, oh, it's a private IP address, so I cannot access it from the internet, right? Well, just replace the private IP with the public IP address, and maybe it will work. Yeah, sometimes it works. So this is the XML exposing the control points. So this is basically like the SOAP URL, and it will describe the device capabilities, what it can offer. And the most interesting part in this document is the one IP connection service. And I will explain why in the next slide. But what you need to know is that this is the second vulnerability. This XML file shouldn't be exposed on the internet. It should stay on the LAN. And even if it doesn't contain any credential or secrets, this isn't right. It gives more visibility for an attacker to further abuse the protocol. So what is this one IP connection services? So it's a set of features introduced in UPnP for NAT traversal and generic port mapping functionality. If you look at the documentation, there is one function that is actually very interesting. I don't know if you can read it. This is the Artpop Mapping function. It is being used in the example I showed you with the peer-to-peer client. So you can basically ask the router to redirect traffic to your host. And this is, yeah, basically used for NAT traversal. This function takes at least 4 parameters. The protocol requested, so TCP or UDP, then the internal client, where you ask the router where it should redirect the traffic to, so IP address and port, and then the external port being opened on the WAN interface of the router. So this is where the fun begins, of course, because we can abuse this function, and you can even call it from the internet. So normally, you will provide your private IP address in the internal client parameter, but you can actually change it to anything, right? Because behind the scenes, in most implementation, the UPnP Demon will simply spawn IP tables with your input, like there are no sanity checks. Okay, so that's also why you get a tons of remote code execution on UPnP Demon, because yeah, just spawn system IP tables with your data. And you get that 200 OK, and this is it. You can use the router as a proxy and connect to your target. So, of course, well, this is bad. And there are two flows being exploited here. So first of all, the SOAP invocation. I mean, it shouldn't be allowed from the internet. And secondly, the internal client parameter should be a private IP address. Like, simple stuff, but, you know. And this is a payload, the SOAP payload. So SOAP is basically, if you don't know SOAP, it's basically like a fancy HTTP. So this is like a post request with a few things more. But so this is the post request. And I like my packets to be as close as possible to the legitimate one, but you can do a much smaller payload. So you have the SOAP action header, and you just ask for the Artpop Mapping function, and then the interesting parameters are new internal client, which you can specify your target IP address, the inbound port, which can be a random port you choose, and destination port where you want to go. Okay, so time to do a small demo. Oh, okay, just went to sleep. Sorry about that. All right. I will duplicate. Right. So there we go. So this is just, I'm sorry, it's really small, but just to show you guys that it's really simple to exploit and to find new routers. So this is a small script I've made running on a VPS, and I am rate limiting myself. And just to show you that in 60 seconds, I can find like 10 routers being vulnerable to this in many countries. So I got a lot of M-search reply, so a lot of UPnP devices out there, and some of them being vulnerable to this. Well, we can go to this slide now. Thank you. So, yeah, this is quite an issue. Time to do some research. Let's scan the planet with this script. So, I found out that UPnP-enabled devices account for almost 0.5% of all the IPv4 address space, which is, I mean, it's small, but it's kind of huge when you compare to other services. And among those, 12% are being vulnerable to the open forward attack. That's quite a lot because it's 260,000 online right now devices being vulnerable. And you have, like, most vulnerable operators are located in Southeast Asia, which is why I guess that it's more or less an ISP issue, like misconfiguration happening from there. And the good news, though, is that this number of vulnerable devices is declining. Like, I've been doing scans in November and a few days ago, and the numbers are like declining. So good news. But it's still a lot. Here is just a heat map to show you. So there are blue area around the world, but especially in Southeast Asia. Some close-ups, so throughout Europe, and yeah, a lot of them in Korea and Japan, and also in China. So putting it all together, this is what the Inception Group have been doing like for years, chaining 3 layers of routers to anonymize themselves. It's really easy once you get the trick, like Artpop Mapping, and then you can basically use like proxy chains and go to the next router using the previous one and chain as many nodes as you want. So I guess they wanted to do like a parallel Tor network because 3 nodes, it's like the Tor network. And about this botnet, because we can call it a botnet because they are made of compromised router. So even if there is no payload, well, I mean no binary, it's still a botnet in my book. So there is a large set of nodes located in more than 80 countries. It's 40 times more nodes than actual Tor relays. So I guess why maybe the threat actor have been choosing this technique. And also minimal footprint, no implant are necessary, you just use the protocol, and logs are really hard to get on those devices, so really like no traces. Also you get residential IP addresses, which is kind of good because you are not being blacklisted. But yeah, it's kind of slow, that is true, and there are no encryption, so. But wait, like, hold on. How did the researchers uncover this botnet? Like, how did they find out the threat actor have been using exactly 3 layers of routers? Can you guess? Like, it's time to be hacker man. So, say hello to this little UPnP function called getGeneratePortMappingEntry, which doesn't really need some fancy documentation to guess what it can do. So you can query the router and actually get a list of all active entries, including the ones that are added using the Artpop Mapping function, which is kind of cool, because with this, well, let's track the Inception Framework group. So what you have to do this is just scans for all the UPnP hosts on the planet and send getGeneratePortMappingEntry request, and if you get a reply, well, the device is vulnerable, so okay, cool. And also you will get like a list of all the entries going on. So if you see like a public IP address in the port mapping entry, there is something really fishy going on. So for example, if you get a reply from this one and you say, okay, oh, I get, there is an active connection from C to some other IP like in South America, this is weird, I will keep it in mind. Oh, and on this router there's another active entry going to B to C, and on this one you can have a connection, not a connection, but an entry on A to B. So this way you can really like trace back the Inception framework. I have just one small question for Symantec, is because with this technique, you cannot find the origin. So I don't know how they could tell there were VPS server involved, but it's interesting to know. This is not it. There is a counter hack to this, so ought to be like a ghost. Small trick. So it's easy, actually. After a successful port mapping, just make your connection, and then you can invoke delete port mapping. And of course, delete port mapping, well, it won't close your TCP session. Once your TCP session is established, well, it's like I told you, IP tables behind. So if you remove a rules, your TCP session, if it's open, it will stay established. And then if a third party tries to query the router for any port entry, he won't see anything. So this is one way to be like invisible. Some other threat actors have been using the same bug, this time discovered by Akamai and published in November last year. So what is this all about? What this threat actor have been doing is quite smart. He wanted to exploit the eternal blue vulnerability on computers that were behind NAT and used UPnP to directly connect to its target, so from the internet. And I really think that Akamai should have called that external blue. Yeah, I don't know. But yeah, they actually named it after the signature they found on the packet. So the description, actually in the SOAP, you have an optional parameter called description, and this threat actor have been writing Galeta silenciosa, I don't know why, in the SOAP. So that's one way to make yourself detectable. So yeah, and then once the port is open, you can exploit the computer. More hacks. So this can be further abused for discovery of internal hosts with the fact that private IP addresses are easily enumerable. Just go through all known ports and fingerprint internal host. and you can access then sensitive data, like storage, printers, and stuff like that. Given the fact that most people give little attention to their internal security, this can pose a huge risk for owners of vulnerable routers. Last UPnP hack for today, so LAN host config management service is another set of features being offered by UPnP, and guess what? Not only can you get internal parameters such as domain name, DHCP, or DNS server, but you can actually set them. Whoa. Yeah. And, well, this function speaks for itself. You can guess it's pretty dangerous if your router is being vulnerable and exposed from the internet. You can change the DNS server, which is kind of critical, in my opinion. So, yeah, UPnP hacks are still a thing in 2019. There have been years of abuse by multiple threat actors, and what is interesting here is it's really like no code, no crime. Like in Windows environments, you have a lot of malwares, of course, but you have also a lot of antivirus and telemetry, so you can detect them pretty easily. Here, it has been low, like it's been low-key, using like, I think for 5 years it has been detected for at least 5 years. So, yeah, you can go unnoticed with techniques like this. And yeah, so yeah, patch it or disable it now, but I guess it's more like misconfiguration going on. So operators need, or ISP need to do something about that. Here are my references I use for this research, and thank you very much.